Okay, good afternoon class. So this is the video discussion about the chapter 2 of your biochemistry class, which is all about stereoisomers. So I've divided the chapter 2 into two parts, and this is the explanation for the first part. Okay, let's have a quick introduction. Okay, so have you seen a child trying to wear his or her slippers? So sometimes they napagpapalit nila yung left slipper and the right slipper. Okay? So the left and the right concept has something to do with the stereoisomers. Okay? So magkakalituan tayo dito sa left and right kapag diniscuss natin ito. So okay, let's start. Okay, you have stereoisomerisms. Okay, so biomolecules are all made up of organic compounds. So again, what are organic molecules? The four major organic molecules are the lipids, the proteins, the carbohydrates, and the nucleic acids. Okay, so sabi dyan, biomolecules are all made up of organic compounds. So when you say organic, again, made of carbon, hydrogen, oxygen, and nitrogen. Okay, so sabi dito, you have organic compounds exhibit isomerism. So meaning the organic compounds comprising your biomolecules, they show isomerism. So what are isomers pala? You have isomers have different physical and chemical properties. So chemical and physical properties na inyong isomers are different. So there are two types of isomers. You have the structural isomer and the stereoisomer. Okay, so ano ba yung when you say molecules possess similar but subtle structural differences. Okay? So, meaning, yung molecules the molecules of the biomolecules, the molecules comprising your biomolecules have similar yet they are similar yet they have subtle structural differences. So, magkakaiba-iba yung kanilang structures. Okay. So, sabi nga natin, you have two types of isomers, the structural isomers and the stereoisomers. So, stereoisomers exist in the structure of biomolecules in which the optical activity is determined. So, again, nakikita lang yung stereoisomers in biomolecules with optical activity. Okay, so the biomolecules could be enantiomers. Okay, so you have enantiomers, racemic mixtures, diastereomers, mesocompounds. So yan siya ang apat na types ng biomolecules in stereoisomerism: enantiomers, racemic mixtures, diastereomers, and mesocompounds. So these concepts are vital in the understanding of characteristics of different biomolecules. So, bakit? Molecules possess similar, sabi ko nga, they possess similar, subtle, and structural differences which can have a major impact in their chemical reactivity. So, yung pagkakaiba-iba, subtle structural differences sa ating mga molecules will have an impact when it comes to their chemical reactivity. Okay, next. Okay, so learning outcomes for this chapter will have, at the end of the lesson, the students are expected to describe the different types of isomers and then define the plane polarized light. They will also be able to discuss the optical activity of a molecule, distinguish the asymmetric and symmetric carbon atoms in a given formula, illustrate the structure of molecule using projection formula. So, writing of projection formulas are included. Kaya nga sa inyong activity, pinasulat na kayo doon ng structural formulas locating the chiral carbons. Okay, so explain and predict if the substances are enantiomers, racemic mixtures, diastereomers, and mesocompound. And plan a mechanism to be used to know when a substance is optically active or not. So, mamaya malalaman natin kung ano ibig sabihin ng optical activity. Okay, first, baka nalito na kayo, ma'am, what is isomer? So, here is the review for isomers. Okay, can you tell your left from your right? So, kunin ang mga kamay. Okay, tingnan mo. Okay, so saan ang left na kamay? So, if sa akin nakaharap, this is my left and this is my right. So, our bodies are reasonably symmetrical. When you say symmetrical, it shows, so, the left side is the mirror image of the right side, and the right side is the mirror image of the left side. So, you have left and right. So, kumbaga, when you place your left hand in a mirror, di ba? Yung sa mirror image na yun, pareho ng right hand. So, the right hand is the mirror image of your left hand, and the left hand is the mirror image of your right hand. Okay, so symmetrical kasi yung ating body. When you say, pag hinati mo sa gitna, pareho ang parts na nakikita sa left and sa right. Yet, there is a difference if we try to put a left-handed glove on our right hand or a right shoe on our right foot. Diba? Tama. Pareho sila. Mirror images sila. Pero, kapag sinuot mo ang right glove dito sa left, hindi magkakasya. Ganon din sa sapatos. Kasi kapag pinagpantay mo sila, hindi naman sila mag-coincide, correct? Pareho sila, mirror images, but they don't coincide when placed on top of each other. So that is, these subtle differences in structure is what stereoisomer attempts to explain or define. Yan yung pinadaling explanation, no, kung para saan ba ang ating topic na stereoisomers. It attempts to define the subtle differences in structures of biomolecules. Okay. So, similar to molecules, so, yun nga, has subtle structural differences. So, these subtle structural differences forms a major impact on their chemical reactivity. So, ano example natin dyan? You have two forms of blood sugar. So, ano ang blood sugar natin? You have the glucose, correct? So, glucose. So, actually, in the body, there are two types of blood sugars, or there are two forms of blood sugars, but only one of these structures can be used to, or can be used by our body for energy. Meaning, doon sa dalawang forms na yun, isa lang ang ginagamit para sa energy of the body. Okay, so isomerism, a phenomenon of two or more compounds having the same number and kinds of atoms. So, this is the definition of your isomerism. So, ano yun siya? Meaning, there are two or more compounds, dalawa or more compounds having the same number and kinds of atoms. Meaning, meron siyang equal na numbers ng atoms and pareho din yung types of atoms na yun or kinds. So, example natin dito, you have the hexane and the 3-methylpentane. So, 1, 2, 3, 4, 5, 6. So, 6 carbons, kaya ang hexane. And then, 1, 2, 3, 4, 5, 6. 6 din na carbons ito. Pero, magkaiba sila ng pangalan. Kita nyo? Iba sila ng compounds, but they both have 6 carbon atoms. Next, you have the butane and the 2-methylpropane, or in short, isobutane. Okay, so your butane, ang structure, kanyang chemical formula, CH2, 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 CH3. Ilan ang carbon? 1, 2, 3, 4, apat. And then, you have 3, 5, 7, and 9. 9 na hydrogen atoms. Dito sa 2-methylpropane, you have 1, 2, 3, 4, then 4 din na carbon atoms. And then you also have 3, 5, 7, 3, 6, 7, 8, and 9. So, pareho, di ba? They have the same kind, they are comprised of the same kind of atom and also same number of atoms, but they have different names. Why? Because nagkaiba sila sa structural arrangement. Okay? So, yan yung ating isomers or isomerism. Magkakaiba-ibang compounds but they have the same number and kind of atoms. They just differ in the arrangement of the atoms. Okay. So, yan. You have the phenomenon of two compounds having the same number and kinds of atoms. So, you have two types of isomerism. Okay, two types. Dito natin i-discuss. Here we will discuss the different types of isomerism. You have structural isomerism and stereoisomerism. Okay, first part or first type is the structural isomerism. So, it's defined by the difference between isomers is due to different structural arrangements of the atoms that form the molecule. Again, yung difference dito sa ating isomers is due to the different structural arrangement. So, yung example natin kanina, those were structural isomers. Sa arrangement sila ng atoms nagkakaiba. So, example, you have 1 bromopropane is having the same number or pareho lang sila ng atoms, ng kind ng atoms and number of atoms, pero magkaiba ang pangalan nila. So, itong nasa taas, 1 bromopropane, and then itong nasa baba, 2 bromopropane. So, bakit? You have 1, 2, 3 carbon atoms, and then 1, 2, 3 carbon atoms din. So, propane yan siya. Ngayon, the names are different because of where the bromide is connected. So, dito sa ating first 1 bromo, because nakakonect ang bromide sa first carbon atom. Kaya 1 bromo propane. On the second one, saan siya nakakonect? Okay, so your bromide is connected sa second carbon atom. Okay? Bromide or bromine. Bromine yan siya. So, you have, nakakonect siya sa second carbon atom. Kaya, 2. So, again, yung numbers dito sa unahan, those are numbers indicating kung saan na carbon nakakonect ang inyong metals or alkali metals. Okay, so, bromine nakakonect sa second carbon. So, 2 bromopropane. Next, you have propanol and propanone. Okay, so dito, ganun din. Same numbers and kinds of atoms, pero magkaiba sila sa structure. Okay, so nakuha na yung structural isomerisms. The difference is due to the different arrangement of atoms. Or different structural arrangements of atoms. Next. Okay, so example pa rin ito siya. So, ito, for example, ito. 1 chloropropane and 2 chloropropane. So again, 1 chloro because your chlorine is located or is attached or bonded to the first carbon atom. While dito, 2 chloropropane because the chlorine is attached to the second carbon atom. Okay. Next. Okay, so the second type of your isomer is the stereoisomerism. So ito yung lesson natin. This is what our lesson is all about. Stereoisomerism. So when you say stereoisomerism, the isomers have the same structural formula but differ in the spatial arrangement of atoms. So ito same sila ng structural formula. Pero, nagkakaiba sila sa spatial arrangement of atoms. So, mamaya makikita nyo kung anong binabanggit dyan sa spatial arrangement of atoms. So, meron kang two types ng stereoisomers. You have the cis-trans or the geometric isomers and the optical isomers. So, again, cis-trans or geometric. Iisa lang yan sila. And then you have the optical isomers. Okay, so example ng cis-trans. Yeah, geometric isomers. A muna tayo sa cis-trans. The atoms differ in arrangement in the double-banded carbon in the structure. So again, saan mo makikita ang difference in the arrangement dito sa geometric isomers? Sa second or sa double-banded carbon in the structure. So, when you say double-banded, doble ang bonds na makikita mo. So, this is a single bond kasi isang line lang. When you say double-banded, dalawa ang bonds. Double bond or double ang linya. Okay. So, the difference in the cis and the trans can be seen on the different functional groups na nakadikit doon sa dalawang carbon or double-banded carbons. Again, ano ang functional groups? Different types of groups like alkanes, ayan, nandoon yan sa first chapter natin. So, functional groups, sample natin is alkane. So, ito, you have methane. So, carbon with 3 hydrogens, okay, is methane. And then, meron pang other na functional group na makikita is your hydrogen. So, when you say cis, meaning you are what? The functional groups are parallel. Kita nyo, both the methanes are on the same side. Okay, so when you say cis, it means the functional groups are on the same side. So, magkakapareho. Okay, so you have H or hydrogen atoms dito na sa baba, and you have methane compounds or molecules dito sa taas. On the other hand, trans to butene naman, when you say trans, meaning on the other side. So, magkabaliktaran sila. So dito, you have carbon is attached to nasa taas ang hydrogen, nasa baba ang methane. Sa kabila naman, nasa taas ang methane, nasa baba ang hydrogen atom. So, meaning, para siyang nag-criss-cross. So, kapag ganon, trans, yan siya. Geometric isomer. Kapag parallel sila or both on the same size, magkapareho, then cis. Okay? So, next is the optical isomers. Optical isomers. So, these are the compounds have the ability to rotate the plane polarized light. So, this is the focus of the lesson. So, dito yung geometric isomers kasi, pahapyaw lang siya, no? So, the lesson on stereoisomers will focus on optical isomers. So, again, your optical isomers, they have the ability to rotate the plane polarized light. Okay. So, yan. Example natin ng cis-trans. Ayan, kanina. So, meron pala, nasali ko siya. So, you have the prefix cis in Latin for, when you say cis, it is a Latin word for the side of. So, cis indicates that the functional groups are on the same side of the carbon chain. So, ayan. Diba? Sabi ko nga, on the same side sila yung functional groups natin like the methane. On the other hand, you have prefix trans in Latin. So it means on the other side. So trans indicate that the functional groups are on opposing sides of the carbon chain. So nasa magkaharap sila ng opposing sides. So parang nag-criss-cross. Okay. So what are optical isomers? Ito na yun. So, optical isomers have the ability to rotate the plane polarized light. So, this forms a compound that have the same structure. Again, your optical isomers, magkakapareho ang structure nila but are mirror images of each other and typically differ in optical activity. So, tingnan ng example. So, same sila ng structure. When you say optical isomers, these are compounds with the same structure. So, para silang mirror images of each other. Correct? Para silang left and right hand. So, nakita, carboxylic group here, COOH, then dito, carboxylic group din. Nasa left side ang methane, sa kabila, nasa right side siya. But, the H and the NH2 are both on top and bottom. So, mirror images sila ng isa't isa, but their optical activity differs. So, yan ang optical isomers natin. Okay. So, you have structural. Okay. Mamaya na yung diagram mo. Okay, punta na tayo sa plane polarized light. So, ano ba yung plane polarized light? Kasi nabanggit kanina. Okay, so your plane polarized light is the light that is vibrating in only one plane and is called plane polarized light. Okay? So, isa siyang light, your plane polarized light is not a normal light. Bakit? Yung ordinary light natin or unpolarized light, ordinary light is consisting of electromagnetic waves which are vibrating in all directions or planes perpendicular to the direction it is traveling. Nakita nyo, ito ang ordinary or unpolarized light natin. For example, so the electromagnetic waves ng ating normal light is vibrating in all directions. Kita nyo? So sa lahat ng directions, meron siyang electromagnetic waves traveling in all directions perpendicular doon sa kanyang totoong direction kung saan siya nagtatravel. So, saan ang direction niya? Dito sa gitna. Meaning, papunta sa observer. Kuha? Pero ang ordinary light, ang kanyang mga electromagnetic waves are vibrating in all direction. Kuha? So, iba-ibang direction siya. And then, using a polarizer, the ordinary light emerges vibrating in only one plane. And by then, it is called a plane polarized light. So, itong ordinary light natin, gagamitan mo siya ng polarizer in order for it to be converted into a plane polarized light. So, when you say plane polarized light, it only has one plane. Okay, nakuha. Isa lang ang plane niya. Unlike kanina na in all directions ang kanyang plane. Okay, so to understand this, for example, let us have the light at home as an ordinary light. Okay, so as you can see, the light is spread in all directions. So, for example, yung ilaw ngayon, so diba, nasa lahat ng direction siya, hindi naman pwedeng magkailaw ka na straight lang ang line ng light, diba? Okay. So, example natin yan. So, yung ilaw sa bahay ninyo. So, spreading in all directions yung kanyang electromagnetic waves. However, if you place a black paper to cover the light, with only one opening to the filter, to filter the light, then it becomes polarized light. So, for example, try nyo, kung meron kayong bumbilya, and then, kuha kayo ng cotton band, butasan nyo ng straight line, and then i-cover nyo sa kanya. So, diba, lulusot, yung light na lulusot is only in one plane. So, yan yung ating plane polarized light. Okay, so yan. Eto. Example, ito yung unpolarized light natin. Vibrating perpendicular. Diba? And then, i-add mo siya. So, the light will be passed through a Polaroid filter. Kasi yung example natin ng isang polarizer is the Polaroid filter. So, iisa lang ang plane na pwede sa ating Polaroid filter. So, the other perpendicular line, or yung ibang electromagnetic waves that are traveling perpendicular to the real direction, will be gone. So, ano lang matitira? Yung isang plane lang ng polarized light. So, when ordinary light passes through a polarizer, it emerges vibrating in only one plane. So, after nun, that is what you call the plane polarized light. Okay. So, plane polarized light are usually made from one, pwedeng calcite. Number 2, pwedeng tourmaline. So, this should be TOUR. Again, so TOUR yan. Tourmaline crystals. Hindi yan tourmaline ha. Mali yan. TOUR yan dapat. Tourmaline crystals. And then, pangatlo, pwede rin yung Polaroid filter. So, sino sa inyo may mga Polaroid? So, yun. Polaroid filter is one example of a polarizer. So, your Polaroid is a transparent plastic, or Polaroid filter is a transparent plastic that contains properly oriented embedded crystals. So, two Polaroid filters with parallel access allow passage of plane polarized light. So, actually, kailangan mo ng dalawang Polaroid filters to produce a plane polarized light. One in the beginning and then another one at the end. But when one filter is placed, so kailangan parallel sila. So, for example, ito yung ating ito yung ating Polaroid filters. So, kailangan parallel sila. Okay? Parallel sila in order for parallel access sila para ma-allow yung passage ng polarized light. Kuha. Pero kapag yung isa, but when one filter is placed so that its axis is at right angle to that of the other filter, the passage of light is blocked and the filter appears black. Kanina, kapag parallel, there is the passage of plane polarized light. Pero kapag pinis mo siya ng perpendicular to each other, so, mabablock yung passage ng light. Kasi nga, dapat parallel sila para magkaroon ng isang plane. Kapag right angle sila with each other, perpendicular, then there's no passage for your light. Kuha? So, magiging black yung, the filter will appear black. So, no light will pass through. So, dapat parallel ang iyong dalawang Polaroid filters. Okay. Okay, so the polarimeter measures the rotation of the plane polarized light. So, kanina meron tayong Polaroid. Your Polaroid will allow the passage of a single plane for your plane polarized light, correct? Ngayon, ano yung nagme-measure ng rotation ng ating plane polarized light? You call that as polarimeter. Okay, so what are the essential features ng inyong polarimeter? It is composed of number one, light source. So, yung light source natin usually is sodium lamp. Sodium lamp. Next, yun na, polarizer. So, yung polarizer natin is a Polaroid filter. Next, sample tube. So, dito nilalagay yung sample ng substance. na yung, because polarimeter kasi, mini-measure mo or you are trying to observe if the substance is able to rotate the plane polarized light. Kaya, meron kang sample tube. Dito mo nilalagay yung substance na iyong tinitest if it will rotate the plane polarized light. Next, you have the analyzer. So, ito na yung pangalawa mong polarizer. Okay, kuha. So, di ba sabi natin kanina, you need two Polaroid filters in order to produce a plain polarized light. Ngayon, meron kang yung una is the polarizer and the second one is the analyzer, another match polarizer. And then lastly, you have the calibrated scale, 360 degrees for measuring number of degrees the plane of polarized light is rotated. So, ito na siya. Your calibrated scale, 360 degree, is the one that measures the change of or the rotation of the plane polarized light when a light is being passed through your sample contained in the sample tube or the sample substance. So, kung gaano ka optically active yung sample mo na substance, ang calibrated scale ang magme-measure niyan. Kasi i-measure niya yung degree na kung paano nag-rotate ang plane polarized light in the presence of the substance you are testing. Okay, next. Okay, so the rotation of plane polarized light is quantitatively measured using a polarimeter. So, ito na example ko. Mas pinaikli ko lang yung naunang slide, no? Pero ito ang kanyang buong explanation. Okay, so the calibrated scale is the instrument is made up of light source, sabi ko nga, sodium lamp, polarizer, sample tube, analyzer, and calibrated scale 360 degree. So, the calibrated scale is attached to the analyzer. Saan nakadikit ang calibrated scale? Doon sa iyong analyzer. So, when an optically inactive substance is placed in the sample tube, when you say optically inactive substance, it does not rotate the plane polarized light. So, meaning, walang rotation na nangyayari kasi optically inactive man yung substance na nilagay mo. So, the axes of the polarizer and analyzer are parallel and the scale is at 0 degrees. Okay, so mamaya may picture ako ipakita sa inyo. So, again, ito yung polarizer mo. Ito naman ang analyzer, nasa dulo. Okay, so yung pink. So, kapag optically active ang nilagay mo na substance, magkakaroon ng rotation ng light, okay? Ng plane polarized light. So, ang nangyari, since ang analyzer connected sa kanya yung ating calibrated scale, so kapag nag-rotate ang light, galing dito, kapag nag-rotate siya dahan-dahan, ganun din yung rotation ng inyong calibrated scale. So, dapat mag-rotate siya. But, if inactive yung substance, walang rotation na mangyayari kasi nga, optically inactive yung substance. So, no rotation will occur. So, hindi rin gagalaw yung ating calibrated scale. So, parallel lang siya. Kuha, kapag optically inactive yung substance mo. Okay, so 0 degree pa rin siya kasi hindi naman siya nagbago ng degree. On the other hand, when an optically active substance is at the sample tube, there is a rotation of the plane through an angle. So, yung symbol ng angle natin is letter A, as a result of vibration of the polarized light. The analyzer is then rotated to the position where the emerging light is at maximum intensity. So, the number of the degree and the direction of rotation by the solution are read from the scale as the observed rotation. So, sabi ko nga kapag ito yung ating polarizer and then ito ang ating analyzer. So, kapag optically active, mag-rotate ang plane the plane of the light. So, magkakaroon ng rotation din sa iyong calibrated scale. And then, yung degree ng rotation niya, yun ang sinusukat ng calibrated scale. Okay. So, So, ito na ang example natin. Itong example ng isang polarizer. Or, example ng isang polarimeter. Okay. So, kita nyo, you have the light source. So, ito yung ating sodium lamp. For example, the sodium lamp. It is the light source. So, these are the light vibrations in all planes. Kasi sabi nga natin, yung normal na light, its electromagnetic waves are traveling in all directions or perpendicular, tama? So, light vibrations in all planes, in all directions. Then, you have here the first polarizer. Okay, so yung polarizer mo, you have the polarizer. After mag-pass through ng light from the light source or your normal light through the polarizer, magiging plain polarized light na lang siya. So, isa na lang ang plane ng light mo. Kasi nag-pass through naman siya sa number 1 polarizer. So, single plane. And then, after that, this is the optically active sample solution in a tube. So, ito yung sample tube mo. Kuha. Dito nakalagay yung iyong sample ng solution. So, yung solution, tinitest mo if it can rotate the plane polarized light. Kuha. So, dito ang sample niya is optically active. Meaning, when you say optically active, it is able to rotate the plane polarized light. So, galing sa vertical line, pag-pass through ng light dito sa ating optically active solution, the plane polarized light rotated at a certain degree by the solution. So, dahan-dahan siya nag-turn into horizontal. So, yan yung sinasabi natin na rotation of plane polarized light. Nag-rotate siya from vertical into horizontal. Why? Because the substance or the solution you've placed in the sample tube is an optically active substance or solution. Kuha? So, after nyan, kapag the plane polarized light passes through your optically active solution, so ang kanyang degree, ilan ang degree ng kanyang rotation? 90 degrees, tama? Because from vertical, it was rotated into a horizontal line. Kuha? So, yung degree ng rotation, that is the one that is measured by your calibrated scale. So, ang symbol ng rotation is A for angle. Okay, so the analyzer scaled to read rotation angle in degrees. So, lastly, ito na yung iyong eye. So, ito yung observer. So, nakuha. Okay, next. So, the formula. So, dito natin ma-encounter ang formula for your specific rotation. So, again, the unit for your specific rotation or the symbol for the specific rotation is letter A for angle. Okay. So, your specific rotation is the number of degrees that the polarized light would be rotated by passing through 1 decimeter of the solution of the substance at a concentration of 1 grams per ml. So, sabi nga natin, when you say solution, meaning your substance was being dissolved in a liquid. Okay? So, the amount of the solution is 1 decimeter and in a concentration of the solvent, 1 gram per milliliter. So, the specific rotation of an optically active substance varies with temperature, wavelength of light, and solvent use. So, you can use different types of solvent when you are preparing the solution of your substance, your active substance. Okay, so yung pagiging effective niya, the effectivity of the substance in rotation of your plane polarized light depends on the temperature of the preparation, the wavelength of the light, that you're using and also the solvent you've used to dissolve your active substance. So the wavelength usually used is 589.3 nm or nanometer. So nm means nanometer, which is the D line of sodium taken from a sodium vapor lamp. So sabi nga natin, usually ginagamit natin in a polarimeter is a sodium lamp. Okay. So to calculate specific rotation of the polarimeter data, the following formula is used. So ito yung formula natin. You have specific rotation, A is equals to observed rotation in degrees. So the value for this, dapat degree yan siya. Value degree. Divided by the length of sample tube in decimeter times the sample concentration in grams per milliliter. So, milliliter ito dapat. Okay, so example natin. So, you have the example for calculating for the specific rotation of your plane polarized light. Okay, so a sample containing a single enantiomer of fluoxetine is analyzed using a polarimeter. So, you are trying to analyze the fluoxetine through a polarimeter. The observed rotation is 9.06 degrees clockwise direction. So, clockwise. The sample was prepared by dissolving 1.24 grams of fluoxetine in a solution with 2.62 milliliters of distilled water. So again, ang ginamit niya na solvent is distilled water. The source of light was a sodium D line or yung sodium lamp natin. So the length of the sample tube was 1.25 decimeter. So nandito na lahat yung given values for the formula. So using the formula kanina, specific rotation is equals to yung degree ng ating rotation. So, binigay niya na 9.06 degree clockwise direction. So, bakit important? Again, the direction of the rotation is very important because in here, the value will be positive or negative depending on the direction. So, when you say clockwise, meaning the plane polarized light rotated in a clockwise direction. So, when clockwise, the value is positive. Kapag counterclockwise naman, negative ang value. But dito sa example, since the given value was in rotating in a 9.06 degree rotating in clockwise direction, then positive. So, you will place here the value positive 9.06 degrees. Diba? Divided by 1.24 grams over 2.62 milliliter times 1.25 decimeter. Okay? So, ito yung value ng sample tube, yung length ng iyong sample tube times the value of or gaano karami yung substance na dinisolve, so 1.24 grams over yung kanyang solvent, gaano karaming water ang ginamit, 2.62 ml. Okay. So, using calculator, you will get the value of positive 15.3 degrees. So, pwede rin, you can also get a negative value if the given direction is counterclockwise. So, since clockwise ito, positive 15.3 degrees. Okay, next, optical activity. So, how will you know if the substance is optically active? So, when you say optical activity, the ability of a substance to rotate the plane polarized light is called optical activity. So, a substance that is able to rotate your plane polarized light is optically active. Okay. Okay. So you have here, the plane of polarized light is rotated when plane polarized light passes through an optically active substance. Again, hindi the plane of polarized light will not be rotated kapag yung substance na yung tinest is optically inactive. So, it will only rotate if the substance is optically active. So, you have two types of substance. You have the dextrorotatory and the levorotatory. So, you call the substance dextrorotatory if it rotates the plane polarized light in a clockwise direction. Okay, kuha. So, you will call the substance dextrorotatory kapag na-rotate niya yung plane polarized light in a clockwise direction or to the right. So, the value of the optical activity of your dextrorotatory is positive because the direction for it is clockwise. While the levorotatory, the value is negative because its rotation or the direction of the rotation is towards the left or counterclockwise. So, two types ng substances based on their optical activity. You have dextrorotatory and levorotatory. For example, your quartz. So, a mineral that rotates, your quartz is a mineral that rotates the plane polarized light. So, meaning your quartz is a optically active substance or solution. However, when you melt the quartz, its optical activity disappears. Okay? So, optically active lang ang quartz in its normal state. But when it is being melted, the optical activity disappears. So therefore, optical activity of crystals is due to an ordered arrangement within the crystals. Okay. So in 1848, si Louis Pasteur, he investigated crystals of sodium-ammonium tartrate. So sodium-ammonium tartrate is a salt of your tartaric acid. Okay, so masyadong curious si Louis, no? So gusto niyang malaman if saan nanggagaling yung optical activity of your crystal. So he observed sodium ammonium tartrate and he found out that it exists as a mixture of two kinds of crystals. So doon pala sa inyong sodium ammonium tartrate, there are two types of, or it is a mixture of two types of crystals. So, Louis Pasteur, being a very diligent man, so he carefully hand-separated the two kinds of crystals. Gamit lang kanyang kamay, he separated the two forms of crystals found in your sodium-ammonium tartrate and made separate solutions for it. So, yung first type na crystal, dinisolve niya, he made it into a solution. The second type, he also made it into a solution. So, the solutions of the equal concentrations of two kinds of crystals rotated the plane polarized light, but in opposite direction. So, yung two types ng crystals na makikita doon sa inyong sodium-ammonium tartrates, both of those crystals are optically active. So, both sila, they have rotated the plane polarized light. But, the difference is on the direction of rotation. So, meaning, one crystal rotated the plane polarized light clockwise. So, positive siya. Dextro-rotatory yung other crystal, while the second crystal, levorotatory naman. It rotated the plane polarized light on the left direction. So, negative. So, he concluded, si Pasteur, he concluded that the difference in optical activity occurred because of a difference in molecular symmetry. So, here, the concept of the left and the right symmetry will have a role. Okay, so again, yung difference daw sa optical activity dahil sa pagkakaiba ng molecular symmetry ng dalawang crystals. Okay, kita nyo. So, these are the two crystals. So, this is the left or the negative crystal, the negative form, levorotatory, and then you have the positive form of the crystal and then the negative form of the crystal. So you have tartaric acid. So can you see they have a plane of symmetry. So ito yung structural formulas ng dalawang forms of crystals found in your sodium-ammonium tartrate. You have the tartaric. So, sabi nga natin, it is a salt of the tartaric acid. So, number 1, you have the tartaric acid, RR, and the SS tartaric acid. Okay, next. Okay. So, yung pagkakaiba sa optical activity, there is a symmetric carbon atom plays a role in it. So, merong kinalaman yung presence ng isang asymmetric carbon atom. Okay, so example, your carbon atom has a tetrahedral arrangement. When you say tetrahedral arrangement, there can be 4 different functional groups that can bond to your carbon atom. Magkakaiba-ibang functional groups ang pwedeng mag-attach sa inyong atom. So, tetrahedral arrangement, 4. So, you have the tetrahedral arrangement of single bonds around the carbon atom makes asymmetric or lack of symmetry possible in organic compounds. So, sabi nga natin, organic compounds are composed of carbon, hydrogen, oxygen, and nitrogen. So, there is a presence of carbon atom in organic compounds. Now, if the carbon atom present in that substance or in that molecule is a symmetric carbon atom, an asymmetric carbon atom, then there is a possible lack of symmetry in that organic molecule. So when you say asymmetric molecule, it is formed when there are 4 different atoms or functional groups bonded to a carbon atom. So the carbon atom is called an asymmetric carbon atom as shown by the following examples. Ito. You have your carbon atom is represented in this structure as a circle found at the center. And in it, there are 4 different functional groups bonded to it. You have functional group A, functional group B, functional group C, and functional group D. So that means this carbon atom is an asymmetric carbon atom because the functional groups in it are 4 different groups. Okay. So, 4 different atoms or groups of atoms bonded to a carbon atom. For example, you have lactic acid. So, you have the asymmetric carbon atom on the center. And then, in it, there are 4 different types of functional groups bonded. So, the first functional group is a hydrogen atom. Second functional group is methane. Third functional group is carboxylic acid, and then the fourth functional group is hydroxide. So, magkakaiba. 4 silang magkakaibang group na nakaband sa iyong carbon atom, which makes that carbon atom asymmetric. Kasi nga, walang plane of symmetry. Okay, so optically active substance must have at least 1 center of the symmetry. Again, when you say optically active substance, ito yung substance that are able to rotate your plane polarized light. Now, one distinction para maging optically active yung substance na yun is dapat meron siyang 1 center of the symmetry. When you say 1 center of the symmetry, dapat meron siyang at least isang asymmetric carbon atom or a carbon atom with 4 different functional groups attached to it. So although there are optically active substances that do not have a symmetric carbon atom, however, their center of the symmetry is due to some other structural features. So meron din daw tayong mga other substances na kahit walang asymmetric carbon atom is optically active sila. But mostly, no, meron silang one or more asymmetric carbon atom. Okay. So, dito na, your hands. Place your hands on the screen. Okay. Superimposable. So, your hands are mirror images of each other, correct? Mirror images of each other sila, as I've said earlier. So, your left hand is a mirror image or a mirror reflection of your right hand and vice versa. But, your hands, your left and right hand are not superimposable. Bakit? When you place them on top of each other, they do not coincide. Okay, nakuha. So, when you say superimposable, these are objects or substances that when their mirror images are placed on top of each other, there is a perfect, it will coincide perfectly. So, one example, these two highlighters. Okay, mirror images sila ng isa't isa. And when you place them on top of each other, they coincide perfectly. So, meaning these are superimposable objects or mamaya makaka-encounter kayo ng superimposable substances. Okay. When you say superimposable, this means that when we lay one object upon another, all parts of both objects coincide exactly. So, ayan, you have your left hand and your right hand. Your left hand is the mirror image of your right hand and vice versa. Okay. But when you place them on top of each other, they cannot be superposed or they are not superimposable. So, this is an example of a chiral object. When an object is not superimposable, that means that is a chiral object. When two objects are superimposable, then that means those objects are a chiral object. So, meaning itong dalawang highlighter, since they are superimposable, they coincide exactly and place up on top of each other, then meaning these highlighters are chiral objects. Okay. So, consider the drawing of CH2ClBr and CHFClBr. So, dito. You have a mirror on this side and another mirror on this side. Okay, so the ball and stick model of the two molecules, CH2ClBr and CHFClBr, and their mirror images. Okay. So, ito ang mirror image ng iyong CH2ClBr. Okay. So, when you place both on top of each other, do they coincide with each other or not? They coincide because you will find on top the functional group, you have the bromine, and then sa bottom, you have the chlorine. And on the other sides, you both have hydrogen atom and hydrogen atom. So, kahit na ipagdikit mo sila on top of each other, they are still the same. So, this is what you call superimposable, meaning this one is a chiral. On the other hand, you have CHFClBr. So, mirror image nila. So, unahin natin yung bromine. So, on top pa rin. Cl on top pa rin. But, dito sa right side, you have the fluorine on the left side. And then, sa kabila, sa mirror image, ang fluorine nalipat sa right side. So, kapag you place them on top of each other, hindi na sila magko-coincide with exactly. So meaning this is not superimposable, and your CHF-ClBr is a type of chiral substance or molecule. So why? Paano naging the other example is superimposable, chiral siya. Bakit ito it is not superimposable and siya ay chiral? Because your CH2ClBr is not a chiral carbon atom. Hindi siya, wala siyang, it has a plane of symmetry. Because yung dalawang hydrogen atoms are both the same functional groups. Magkapareho. So, di ba sabi natin, the chiral carbon atom must contain 4 different functional groups. On this sample, 3 lang. Kasi hydrogen atoms, dalawa ang meron nakaband sa iyong carbon atom dito. While sa other example, so meron kang bromine, chlorine, fluorine, and hydrogen. So, 4 na different functional groups ang nakaband. Meaning, this carbon atom is chiral carbon atom. So, it is not superimposable, and that means this sample or this molecule is, or this compound is chiral, chiral type of chiral type of compound. Okay, next. So you have chiral and a chiral. A molecule that is not superimposable on its mirror image is said to be chiral. So the chiral comes from the Greek word chir, meaning hand. Okay, so yung chiral word came from the Greek word of hand. Your chiral molecules have the property of handedness, which means they are related to each other just like the left and the right hand. Okay, chiral molecules have the property of handedness, which means they are related to each other just like the left and right hand. So yung inyong chiral molecules, they are like the left and the right hand. So an asymmetric carbon is an atom that is called chiral carbon atom, or pwede rin siyang chiral center. Okay, so asymmetric carbon atom, siya ang chiral carbon atom or chiral center. So it is not possible for symmetric carbon atom to become a chiral carbon. Always remember that it should be, or it should have a plane of asymmetry. Okay. Okay, next. Molecules or objects that are superimposable in each other are called achiral. Okay, so when you say superimposable on each other, you call them achiral. Okay, so again, superimposable objects are not they are not considered as achiral. A molecule is not chiral if it has a plane of symmetry. So again, kapag ang iyong molecule has a plane of symmetry, then that means that molecule is not chiral. Okay, some of the examples of chiral objects are golf clubs, scissors, shoes, and corkscrew. Examples naman na ating achiral objects, you have plain ball, baseball bat, and t-shirt and nail. Okay. Next. Example natin, chiral objects. Chiral objects meaning you have right hand and left hand. You have your ear. What's this next sample? I can't identify this object. Okay, achiral objects, you have your chair. So, tingnan, kahit na may mirror sa tabi, it appears the same. Okay? Yung mirror image niya is the same with your object. You have the chair, you have the fork, and the glass. Okay. Next. So therefore, a molecule cannot be a chiral if it has a plane of symmetry. So example natin dito, you have this molecule. So ilan ang kanyang functional groups present? You have the methane, the chloride, the bromine, and the hydrogen. So, apat na magkaiba na functional groups. So, meaning, wala siyang plane of symmetry. Correct? So, meaning this molecule is chiral. Chiral carbon atom. So, it has 4 different atoms bonded to the carbon. Next sample. You have the carbon as a center. Then you have a methane group, a bromine group, and 2 hydrogen atoms. So, sabi nga natin, a carbon atom that is chiral should have 4 different groups present or bonded on it. So, since dito you have 2 hydrogen atoms, so parehong hydrogen atoms ang naka-attach sa kanya. So, meaning this molecule is a chiral because it has a plane of symmetry. Symmetrical ang hydrogen atom sa left and ang hydrogen atom sa right. Next sample, we have chiral na naman molecule because it contains methane, it contains ethane, and it contains propane. So, 1 carbon atom, 2 carbon atoms, and 3 carbon atoms. And then, the last functional group is your hydrogen. So, hindi magkakapareho ang apat, meaning this molecule is chiral. Next, a chiral. Bakit? Because there are only 3 functional groups present or bonded to this carbon atom. Sabi natin dapat 4 na functional groups na magkakaiba. So, the oxygen has a double bond with your carbon. Kaya, 3 lang sila. Meaning, double bonds, 2 bonds, and then the third bond and the fourth bond. So, hindi siya 4 na different functional groups. So, this sample is a chiral. Next, Fisher projection formula. Fisher projection formula. So, molecules of a compound that contain 1 chiral carbon atom occur in 2 optically active isomers. So, kapag ang molecule, it contains 1 chiral carbon atom, so it will occur or it will have 2 optically active isomer form. So, kapag merong present na at least 1 chiral carbon lang sa isang molecule, magkakaroon ka ng 2 forms ng isomers that are optically active. Okay, so this is because the 4 different groups bonded to the chiral carbon atom can be oriented in space in 2 different configurations. So, kapag meron kang kahit isang chiral carbon atom, then that molecule will be oriented in 2 different configurations. Okay, so, for example, you have lactic acid molecule or CH3CHOH, So, ilan ang chiral carbon for your lactic acid? You have the second carbon as your chiral carbon atom because it has the carboxylic group, the methane, the hydroxide, and the hydrogen functional groups. Magkakaiba-iba. So, may isa siyang chiral carbon atom. Okay, so you have 3 ways in representing the molecule, such as, so, meron tayong number 1. So, this is a 3-dimensional structure. And then, number 2, you have this type. So, pinapakita dito yung 4 na bonds with the carbon atom. And then, structure number 3, ang ginamit na lang is a crossed line. So, in this, understandable na nasa gitna ng line, at the center of the line, the carbon atom is located. So you have three different ways of writing the structural arrangement of the lactic acid molecule. Okay, so the geometrical arrangement of the four groups about the chiral carbon, so yung carbon number 2 natin, is the key to stereoisomerism of the lactic acid. So you have four bonds attached to the carbon 2 are separated by equal angles of 109.5 degree. So itong apat na bonds, separated sila by 109.5 degree. So, hindi siya exact 90 degrees. So, baka you will assume seeing these types of structural arrangements, you will assume that the four are separated by 90 degrees. So, hindi yan siya 90 degrees. 109.5 degrees. Okay, so the circle is the chiral carbon. So, para dun sa ating three-dimensional structure, the circle you will find at the center represents the chiral carbon atom. And then the H and the OH are projected towards the observer or you. So, meaning, this here, right here, the darker line, represents that your hydrogen and hydroxide atoms are projected towards the observer, meaning nasa harap sila, projecting on the front. While this the arrows, you will see the gray arrows, so this represents that the carboxylic group and the methane group is projecting away from the observer. So, meaning, papuntang likod, backwards. Okay, so, the darker line represents projecting towards the front, and the arrows of color gray represents that it is projected towards the back. Okay, so the structures 2 and 3 are called Fisher projection formula. So this and these structures, okay, so this structure is second structure, and the third structure is the Fisher projection formula. So they are simpler and easier to use for writing structures of chiral compounds. So you can also use, when writing on the paper, you can also use the three-dimensional structure, but it takes time because you need to draw the circle and the different arrows representing the projection of the atom. While when using Fisher projection formula, it is easier because you can just draw lines, crisscross lines, and bonds. So, mas madali siyang gamitin, especially when you are writing formulas for examination. But the usage of the three-dimensional structure, so pwede yan siya kapag ni-require kayo. For example, sa quiz, write the three-dimensional structure of, so saka pa lang kayo mag-draw ng three-dimensional structure. Pero kapag hindi naman specify doon sa hindi specify sa direction na kailangan three-dimensional structure ang gamitin ninyo, then you can use the Fisher projection formula. Okay, so examples of Fisher projections. You have the carbon atom, the chiral carbon atom on the center, and four different functional groups attached to it or bonded to it. Next, so this is the Fisher projection formula, wherein you are using a darker line to represent that it is projected to the front, and so, pwede rin ito, lines that are forming an arrow. So, that means these lines, pwede nyo siyang gamitin as a symbol that it is projected backwards. Okay, so, and then, pwede rin yung crisscross lines lang. Okay, so, dito, understandable na that the carbon is on the center. So, again, Hindi tayo. So again, the degree between these atoms, these four different functional groups, are not a perfect degree of 90 degrees. It is 109.5 degrees. Kaya nga dito sa 3 dimension, di ba? So hindi naman straight yung kanyang angles. Next. So this is a 3-dimensional representation of the lactic acid. Okay, so kita na yan. So ito yung sinasabi kong lines, no, that forming an arrow. So this type of arrow for projecting towards the observer, so to the front. What? And then this type of arrow naman composed of lines projecting towards the back. So kapag pinasulat kayo, if I require you to write the 3-dimensional structure of a certain molecule, then use this one. Okay? So iba kasi yung nakasulat. By the way, the ones that are on the PDF, nawala yung arrow na ganito. So nawala siya. So pwede niyo siyang sulatan. Ito lang yung natira. That is an error, I guess. So so hindi nasali na copy yung arrow. So you can just place the arrows there. But ito yung sundin natin na type. Okay? When I require you to write a picture, a 3-dimensional structure. Okay, next. So, tapos na natin yan. Okay, number 2. For convenience, sabi natin, you use the Fisher projection formula of the structure 2. So, ang structure 2 natin, kita pa yung carbon atom sa gitna. Correct? So, meron pang carbon atom sa gitna. While, yung structure number 3, wala ng carbon atom sa gitna. As is na siya. So, consider na may carbon atom sa gitna ng crossed lines. Okay. Okay, so ito. In your structure number 2, the groups hydrogen and hydroxide attached to the horizontal bonds are coming out of the plane of the paper towards the observer. So, tandaan. Sa Fisher projection formula, kapag when the functional groups are found on when the functional groups are found on the horizontal line, so ito horizontal, that means that those functional groups or the hydrogen and the hydroxide is projecting towards the observer. So kapag nasa horizontal, yan ang iyong mga atom, meaning papuntang harap, papunta sa observer. And then, when the functional groups or the atoms are placed on the vertical line, meaning they are projecting towards the back. Okay? So, kanina kasi sa ating 3-dimensional, pwede mo silang ma-differentiate with the different arrows used, correct? So, you have the darker arrow and the lighter arrow. But, since lines lang yung gamit natin sa ating Fisher projection formula, then you will base it on the horizontal plane and the vertical plane. So, kapag nasa horizontal yung iyong atoms, that means that those atoms are projecting towards the observer. And kapag nasa vertical naman sila na line, the atoms are projecting away from the observer or towards the back. Okay. So, the molecule represented by this formula is made by drawing across and attaching the 4 groups in their respective positions. Okay. The chiral carbon atom is understood to be located where the lines cross. So, dito sa gitna. Okay. So, there are rules to follow in writing your projection formula. So, meron tayong 3 rules in writing the projection formula. Number 1, it must not be turned 90 degrees. Okay. So, sabi ko nga, the 4 different functional groups in a molecule is separated by a 109 degree angle. Okay. So, you shall not, when writing a projection formula, Fisher projection formula, hindi pwede na i-rotate mo siya by 90 degrees. It must not be lifted or flipped off the paper. So, hindi pwedeng iba-ibahin mo yung kanyang structure, and then it may be turned 180 degree in the plane of the paper without changing the spatial arrangement of the molecule. Okay? So, hindi siya pwedeng i-turn ng 90 degrees, but you can turn it 180 degrees. So, meaning ito, full 180 degrees. 90 degrees, hindi pwede. Full 180 degrees, pwede. Okay. Example. You have the structure here, structure number 3. So, i-rotate mo siya by 180 degrees. Okay, so your COH or your carboxylic group, when you rotate it to 180 degrees, it will replace the methane. So, pupunta siya sa direction na methane. Kuha, and then the methane will replace the carboxylic group. Kuha, so 180 man. So, nalipat siya ng 180. So, and then yung methane mo, nalipat naman sa taas. Ganon din sa ating horizontal atoms. Okay. So, you have hydrogen. You will turn it to 180. So, napunta siya sa right side. Kita? And then, your hydroxide atom, 180 degree. So, napunta siya sa left side. So, yan yung rotation natin by, or the turning to 180 degrees. So, kapag sinulat mo siya into, when you write it into a three-dimensional structure, so you have the circle as the carbon center, and then, sabi ko nga, the atoms pa or located at the horizontal line will be projected towards the observer, and the atoms found on the vertical line will be projected backwards. So you have now the structure 4 and structure number 5. Okay. So formulas 1, 2, 3, 4, and 5 represent the same molecule. Pare-parehong same molecule lang sila. Ano lang ang nangyari? You just rotated that into 180 degrees. But that is still the same molecule. Now, what happens if you rotate that molecule by 90 degrees? You will produce you will produce another form of molecule, or specifically, isomer. So, kapag sabi nga natin, doon sa rule, you are not allowed to rotate it by 90 degrees. Why? Because if you rotate it to 90 degrees, then you will produce another isomer, or stereoisomer to be specific. So, hindi na siya yung molecule na binigay originally. Example, Formula 5. So, you have the Formula 5. Formula 4 was made by turning Formula 3 into 180 degrees. So, Formula 5 is the three-dimensional representation of Formula 4. If Formula 3, yung kanina, ito, yung number 3 natin, kapag di-rotate mo siya into 90, or you turn it to 90 degrees, the other stereoisomer of lactic acid is represented. So, sabi nga, nabanggit kanina, your lactic acid has a chiral carbon. Meron siyang chiral carbon. Therefore, it is a optically active. It is an optically active substance. Now, kapag meron siyang isang chiral carbon atom, meaning it produces two forms of stereoisomer. So, yung first form of stereoisomer is yung structure number 3. Ito. Now, if you rotate it to 90 degrees, then you will get the other form of stereoisomer for lactic acid, which is this. Okay, so kapag ni-rotate mo sa 90 degrees, ito, when you rotate it to 90 degrees, you will form, so yung H, or the hydrogen atom will go here, and then your carboxylic atom will replace your hydroxide group, and then so on, forming the structure number 6. Okay, so this, meaning horizontal line. So the ones found in the horizontal line will be projecting towards the observer, and the ones found on the vertical line will be projected away from the observer. So when you draw the three-dimensional formula, this will be the product. You will have the product formula 7 or structure number 7. So these two are the same molecule. So these are both the same molecule, but it is not the same with the original molecule or the original structure given before. So magkaiba. So ito yung second form of your lactic acid. So the projection formula number 6 with a three-dimensional formula number 7 is a different molecule of your lactic acid. Not the same with the formulas numbers 1, 2, 3, 4, and 5. So, ito yung summarization. Okay, so you have your original three-dimensional formula number 1 of the lactic acid. So, this is the number one form of lactic acid. Then, for the formula number 2 and 3, you've turned it into a Fischer projection formula. Two types of Fischer projection formula. Now, in formula number 4, you rotated the formula number 3 into, you've turned the formula number 3 180 degree, forming formula number 4. So, ito na siya. Turn it into 180 degree. And then, dino mo naman yung for formula number 5, you form the three-dimensional structure of formula number 4. Formula number 6, you've turned formula number 3 into 90 degrees, forming this form, the other form of the lactic acid. And then for formula number 7, you've drawn it into a three-dimensional structure. So in your examination, there are situations in which pwedeng ipa-drawing sa inyo lahat ng formulas na ito. So there will be a given instruction on what type of structure you will be drawing. So I advise you to practice drawing different structural formula. That's why I've given you for your first activity how to draw the different structures of the given substances. Okay, so example natin, number 1, draw the projection formula of N3, the dimensional formula for each of the following. So you have CH3, CHBr, CH2 and H2 for number 1. So, ano ang kailangan dyan? Draw 1 Fischer projection formula and 1 three-dimensional formula. And then another for the given number 2. Okay. So, on the exam, I prefer for you to write this type of structure. So, wala na yung carbon sa gitna. So, ang gagamitin natin is the second type of Fischer projection formula in which the carbon center is not seen. Okay? So, the crossed lines, yun ang gagamitin natin sa exam for it to be easier for you to write. So, mahirap kasi yung doing ka pa ng center carbon and then different bonds, 4 na bonds, and so on. So, para mabilisan, line structure na lang tayo or the crossed lines. Okay. For the formula of molecule, so yung sample number 1 natin, you have place the methane group at the top and the Br at the bottom of the vertical line. Place the hydrogen at the left and the is H2 and H2 at the right. So the chiral carbon is not written, which is center of the which is the center or intersection of the cross. Okay, so my advice to you in writing projection formula, kung ano yung nauna na atom or ano yung pinakauna sa formula, yun ang ilalagay ninyo on the top. Okay, so always find first before writing a projection formula. Always find first the chiral carbon atom. So before you are going to write or start writing the projection formula, identify first if the given sample contains a chiral carbon. Okay? So dapat malocate mo muna yung chiral carbon sa given na sample. Now, how to locate the chiral carbon in a given chemical formula? So just check, no? So you have 1, 2, 3 carbon atoms. So find the carbon. You have to find the carbon in which there are 4 different functional groups bonded to it. So let's try to do it. In carbon number 1, how many atoms are attached to it? 4, di ba? So you have 3 hydrogen atoms and 1 carbon atom. Now, does that carbon contain 4 different functional groups? No, because there are 3 hydrogen atoms similar. Correct? So, parehong tatlong hydrogen atoms. So, that carbon is not a chiral carbon atom. Second carbon. So, ilan ang naka-attach sa kanyang functional groups? You have, hydrogen. You have the hydrogen atom, a bromine atom, and then you have attached to it a methane group, CH3, and then you have another carbon atom, or CH2 and H2. So, ilan yon? 4. 4 different functional groups. So, meaning, your carbon number 2 is a chiral carbon. Kuha. And then, for carbon number 3, tingnan natin if chiral ba siya. So, unang tingin pa lang, malalaman mo na it is not a chiral carbon atom because there are 2 hydrogen atoms. So, may dalawa ng parehong hydrogen atoms nakakonect sa kanya. So, meaning, in this given sample, there is only 1 chiral carbon atom, which is the second carbon. So, yung chiral carbon atom, that will be the center of your projection formula, meaning the 4 functional groups revolves around it. So, you will place that at the center and try to place the other functional groups around it. Okay? So, doon sa end ng 4 na lines. Okay. So, after you've drawn the projection formula for that, you can now convert it into a 3-dimensional formula. So, again, when the atoms are located sa sa horizontal line, it is projected towards the observer. And kapag nasa vertical line sila, it is projected away from the observer. So, you will use a darker line and lighter triangle or a lighter arrow for the vertical atoms. Okay. Number 2. So, dito sa example number 2, let's try to locate the chiral carbon atom. Okay, first carbon. 3 hydrogen. So, hindi siya chiral carbon atom. Second carbon. So, ano ang functional groups na nakadikit sa kanya or nakaband? You have 1 hydrogen, 1 methane, 1 methane, and then, meron pang hydroxide, and then, lastly, merong CH2, CH3, or ethane. Okay, so ilan yun? Ethane, hydroxide, hydrogen, and methane. So, 4 different functional groups, meaning your second carbon is a chiral carbon atom. So, meaning siya ang center ng iyong projection formula. So, you will just have to place the other atoms or compounds sa palibot noong crossed lines. So, Yan, you have, sabi ko nga, the first carbon will go on the top, so CH3. You have CH3 on the top, or methane. Next, the hydroxide will go at the bottom part. So, methane and hydroxide, top and bottom. And then you have the hydrogen on the left side, and then you have the ethane on the right side. Okay. So, after you've done the projection formula, you can now convert it into a three-dimensional formula. Okay. So, madali lang, di ba? It's actually fun doing or fun writing projection formulas because you will show your artistic side. Okay? So, mga artistic dyan, magaling mag-drawing. So, pwede kayo It's fun. It's fun placing the different functional groups, trying to locate the chiral carbon atom. So just don't forget, bago magsulat ng projection formula, you first have to locate if the sample has a chiral carbon atom. If the sample does not contain a chiral carbon atom, then meaning it is not optically active. So meaning it does not rotate the plane polarized light. And also, it is not it is superimposable. Okay? Kasi sabi natin, a substance must contain at least one chiral carbon atom for it to become optically active and for it to become not superimposable. Okay. So that's the end for the part 1 of the stereoisomers. I hope that you've learned a lot from watching this video. And if you have any clarifications or questions for this topic, then you can just comment on the post or on this video. Okay. You can also try messaging me through our GC or group chat. So, yeah. So, the second video for this part 2 of your stereoisomers will be posted later on. So, just abang-abang na lang kayo, okay? Thank you and goodbye.